Hi guys, I'm back. Whether you want it or not. Been a while since my last project, hasn't it? Warning, to say that this project is dangerous would be a gross understatement. It is deadly. I did a lot of research and worked with people who know how to not die when handling dangerous chemicals. Do not do this. You will probably die if you attempt to recreate this. This is for educational purposes only. Well then, let's get into it. If you're a gun nut or into airsoft, you may have heard about tritium vials. These little glowing tubes are full of tritium gas, which is a radioactive hydrogen isotope. As it decays into more stable helium, it emits a beta particle, which strikes the walls of the vial, usually coated in a phosphor like zinc sulfide doped with silver. The radioactive particle gives its energy to the powder, it emits a photon, and, in turn, glows. Side note, I'm not talking about phosphorus, which is a completely different thing. Phosphorus is used for making match heads and committing war crimes. Phosphors are just powders that glow when energized, alright? Now then, where does uranium come into the equation? Well, tritium's half-life is about 12.3 years. To put it more simply, in 12 years it'll be about half as much tritium as there was in the beginning due to the radioactive decay. Hence, overall, the radioactive energy being released would also be lower, the tritium lab would glow less brightly. Over time, it would pretty much stop glowing. So I thought to myself, 12 years? We won't even have GTA 7 by then. How could I make it last longer?
I'll be popping bottles. Sparkles in champagne.
I may not have a brain, gentlemen, but I have an idea.
I decided to try and make the lamp using uranium instead of tritium. Why uranium? Because everyone knows it. It's a household name by now. Ask a person to name 3 radioactive elements, if they can even get to 3, uranium will be in the top 2. And I figured plutonium would be a bit more difficult to get because bombs and stuff. Well then, where would I get some uranium? Well, I live in Kaunas, Lithuania. I don't exactly have an abandoned uranium mine lying around. Chernobyl is like, what, 600 kilometers away? That's like at least an hour of walking, man. Gross. Then I remembered that uranium glass exists. It's got a very pretty greenish yellow hue and it fluoresces brightly under UV. I like how it looks. You can switch on the glow with a button. Look, on, off, on, off, on, off. Wow. Regardless of its neat appearance, it is a terrible source of uranium because it was only usually made with a fraction of a % by weight of uranium. Wikipedia does say that some glass are held up to 25% uranium, but despite having these around for a while, none of my limbs nor balls have melted off yet, so I can't put much hope into extracting anything over a few grams of uranium from these. Hold on, this might complicate things. Moving on, how do I get the uranium out of the glass? By using one of the scariest acids known to man, of course, hydrogen fluoride. Why is that so scary? Well, let me read you this answer on Quora, what I found while researching the safety of this project. No. Seriously, no. Treat it like weapons-grade plutonium. It can kill you in a ton of different ways. The fact that it is acidic is not the problem. It is actually classified as a strong acid. This is some of the nastiest stuff a non-scientist will ever encounter. How did you even get a hold of this? And should not be touched by anyone going on Quora to find out about its toxicity. Thanks Marvin. Basically, it melts glass and signal word danger. Ominous pictograms. I don't know, man. Some hand and pipe doing magic and a pirate skull? Hazard statements. Fatal if swallowed, in contact with skin or inhaled. That sign won't stop me because I can't read. But there is good reason for why I chose it. It's because the acid turns the silicon dioxide in the glass into silicon tetrafluoride, which is a gas and most of it just floats away. Yes, you can melt glass in molten sodium hydroxide, which is way less dangerous. Problem is, in sodium hydroxide, the silicon dioxide turns into sodium metasilicate, which is not a gas and it stays in solution, which means I would have to get it out some other way? What am I supposed to do? Filter uranium compounds through a cotton ball? Horrible idea. Albeit maybe not as horrible as using hydrofluoric acid, but yeah, I got nothing. So what do I need for the experiment? Uranium glass, hydrogen fluoride, a container that won't get destroyed by the acid, and something to glow from the radiation when I seal the uranium in an ampule. First, uranium glass. Despite having uranium, this glassware is not very dangerous, so it's safe to keep as an antique. I've had this piece lying around for a while and I bought this one for 25 euros. Next, the acid. It's mildly, fairly, very, extremely difficult to get. I don't know, it might have something to do with the lethal if in your general proximity part. Well, luckily my chemistry teacher had some lying around. Deus Ex Machina hydrofluoric acid, that's a first. Alright, next we need a container that can withstand the experiment. Now, the main selling point of hydrofluoric acid is that it eats glass, so that's out of the question. Luckily, I found this chart that details how well plastics hold up to acids, and high-density polyethylene seems to be our winner. Finally, I need a thing to glow from the radioactivity. The first compound I got was blue glowing silver-doped zinc sulfide. It's how I confirmed that this experiment, however poorly, will be successful. This is a brightened image of the zinc sulfide on one of the radioactive glass pieces. It had been left under a coat in a dark room for 6 hours when I took this photo. However, as you can see, it is very dim. In addition to that, zinc sulfide degrades very quickly and in a couple decades it might not glow anymore. So after doing some research, I found some thallium-doped cesium iodide crystals for sale on eBay in the US. After 2 weeks of playing pinball across the US and another week spent with the Sloss Manning Lithuanian Customs, it had arrived. However, I had made an incredibly stupid oversight. While yes, cesium iodide is one of the brighter scintillators, it emits light in the near ultraviolet. And when I tested it, the emissive light was barely visible. So I decided to stop wasting money and continue with the zinc sulfide. So moving on to the experiment itself, it was fairly simple. I crushed one of the glass pieces and left the other one intact. Why did I do this? I don't know. Then I poured the acid on top of the glass. Now, we're dealing with high-quality Russian hydrofluoric acid, meaning that we do not know what its concentration is. Assuming it's 100%, I calculated that we'd need about 200 grams of acid. However, I was more keen on covering all of the glass, so I used the scientific measurement, also known as eyeballing it, and ended up pouring about 600 grams of acid, which came to bite me in the ass very hard later on. I knew the reaction was exothermic, meaning it released heat, but I thought it would be manageable. However, after I'd left school, my teacher called me and informed me that the container was getting very hot. So I gingerly ran back to school with a bag of ice and put the cup of acid in a bowl of ice water for the night. Next day, the glass had melted, so I put the cup in a pot of water, put the entire thing on a hot plate, and turned on the hot plate to precisely 30 degrees Celsius. And that's about all I did for the next 2 weeks. In the morning I turned off the heating, and after school I turned it back on. However, I kept increasing the temperature bit by bit because the plastic softens at about 120 degrees and the water could never go above 100 degrees and the contents of the cup could never go above 30 until all of the acid boils off. Why did it take 2 weeks? Because I put so much damn acid in. Nearing the end of the second week, I was getting impatient because the next week would be spring break. So I poured off the liquid of the mixture, which should theoretically have most of the uranium, into a second HTP cup. And while said cup was put to boil, I added very concentrated sodium hydroxide solution bit by bit to neutralize the acid in the other cup. The final sealing of the mixture was fairly uneventful. I just mixed in some of the zinc sulfide with the products of the experiment and transferred it into the ampules via my history homework. But after all was said and done, I still ended up sealing most of it in a mayonnaise jar. Instead of having to make a dozen more ampules, I just decided to put all of it in a mayonnaise jar and epoxy the lid. Simple as that. I just cast all of the glassware in resin and it was finally safe to handle. Ta-da! The end. That's it. I don't really have an outro for this video. This project, for lack of a better term, has plagued me for half a year at this point. I'm very tired and I'm glad it's done. Unfortunately, the vials will probably have to be opened or remade by my descendants a couple of decades down the line because the powder stops glowing, but we'll figure it out then. Again, do not do this. You will die. I am very surprised I didn't. Go and find out, my friends. Until next time. Uranium fever that's got me feeling down. Uranium.